Hello students, welcome to the new subject strength of materials and this subject as per syllabi is divided into 4 units and today we are starting with unit 1 and lecture 1, that is simple stresses and strains. Before we go further in detail into the strength of materials, let us first of all try to understand what is the role of civil engineer. As a civil engineer, you have to plan, design, and oversee the construction activities, and ultimately, if required, any maintenance of building, that is, any structure and infrastructure. Now, you can see in the right side, there is a building under construction, and various components of the building are rightly visible. Now, if you see, this is the slab portion. This is a beam, this is another beam, this is another beam, and these are the column. Again, this beam joins between two columns. So column is a vertical member and beam is a horizontal member. Beam supports slab and column support beam, and ultimately through this column we are transferring whole load of the structure to the foundation. That is, superstructure load is transferred to the substructure, that is foundation. Here you can see staircase. So this is a RCC building, that means reinforced cement concrete building. And in another figure, figure number 2, you can see there is a very interesting and good looking steel structure. So that means in a civil engineering field, most of the time we will encounter or we will come across the design, plan, design and construction of RCC building or steel building. Now, very first step is planning. Planning mean, let us say you are given a plot and a plan to construct a residential building or a commercial building, any type of structure. So very first step is you have to plan. Plan mean where you will be installing, or you can say placement of the columns, footing or other component of the structure. Then another important aspect, that is design. Now later on we will be going into detail what is the actual meaning of designing, but for the time being we can understand that each component of the building need to be designed. Now let us, you can see this is a column, and design of column mean you will be deciding the type of the material, cross-sectional area and other components of the structure, that is beam. Now what should be the cross-section area of beam, what should be the material, whether it is concrete or whether it is steel. If it is concrete, then what grade of concrete, what should be the properties of concrete. All these taking into consideration, we will work out the cross-section dimensions as well as the steel, that the type of steel or what should be the area of steel which is going to be used in case of beam or a column. So all these calculations, these workouts come under the field segment of design. Then execution mean after planning, after designing, now you came across the execution of the work. That means now the building will be under construction and you have to supervise all the construction activities so that the plan and designing both should be constructed as per actual requirement. So after that, when building will be under use, that means it is going through its service life, it will be subjected to the purpose, the loads, all type of requirement of the building, and later on there may be some damages or building will be behaving, and you have to maintain the building, you have to do the maintenance of the structure as per the requirement. Now, designing of a structure, that is very important component of the in the life of the structure. That means what is the meaning of designing basically? Very first step is analysis. Analysis means you will be first of all going through the all the details of the material of the, suppose if we are talking about the column, then you have to consider all the details. What should be the, what are the dimensions of the column, what are the cross section dimensions, what will be the support conditions, what type of loads are coming on the column or any structural element. It may be beam or it may be a slab. Accordingly, when load is placed on the beams or columns, then how the column will behave, how any structural member will behave, will it bend, will it crack, etc. So accordingly, you have to do the calculation, and that all the details will come under the analysis part. That means you are, before going to construct a building, prior to construction and prior to designing, you are very much aware about the various type of stresses or behavior of the building in totality. So that will come under the analysis part. Then in designing, after analysis, you will work out the dimensions of the each component of the structure, and ultimately after that you will be applying various checks. Various checks will be according to Indian standard codal provisions, whether the component, whether the structure is following all the guidelines of the Indian standard code, whether the column is going under various type of stresses, whether these stresses are within the permissible limit as recommended by Indian standard code. So these various checks you have to apply. And when we talk about the analysis, as a civil engineer, our role is to design a safe as well as economical structure. That means structure should be safe throughout its life, whatever be the life plan you have decided. Normally, in case of RCC structure, we plan the structure should remain safe for its service life, which is approximately considered nowadays as a 50 years. So that means you have to do the analysis, you have to do the designing, all the parameters, execution, so that your structure should be safe, as well as you can't ignore the economic part. So that structure must be economical also. Now very important aspect is safety and economic aspect of the structure. Before going through all the details, we must be aware about what are the possible causes of failure of a structure. Now we are talking the structure should be safe, and before deciding the safety of the structure, we must be aware what are the possible reasons or causes by which the structure can fail. So that means possible causes of failure of a structure we have to consider. Then how to design a structure to address these causes. In first step, you will be just judging that these are the possible regions of failure of a structure. Now in the designing part, we will be trying to design the structure such that all these regions, all these causes should be taken into consideration, so our structure should be safe. Then how a structure behave when subject to loads and other effects. So that is very prominent part of the any structure, and in this subject this subject will be directly related to the behavior of the structure. That means in this subject we will be able to understand that when a structure is subjected to loads, then what will be the effects of all these type of loads and what will be the response of the structure. Whether There may be one response when you are applying load on the structure, then cracks may occur. That is one type of failure. As we have discussed possible causes of failure, some of the failure causes we can list here, that in cracks. So if cracks are occurring in a structure, suppose your beam is getting some cracks, then we have to think upon what are the possible causes of crack. When crack can occur, what are the various type of cracks? Now you can see in this figure number 1, the diagram we have taken from some sources. You will be finding there are some cracks very much visible. These are the cracks, some cracks. Some are the structural cracks, some are the only cosmetic cracks. That means some of the cracks are only visible and extended to the surface of the structure. They are known as surface cracks. Maybe they are not so much dangerous, but if the crack is penetrating inside the element, that means inside the component, then it will be very dangerous. Because if it is a RCC beam, if cracks are of great width, that means you cracks are responsible that the steel inside the that beam may be exposed to the weathering actions. So corrosion or other type of things can happen, and which will ultimately unsafe the structure. So one of the effect is cracks. Then there may be crushing. You will be able to see many structures which are crushed under the load. Maybe some column are getting crushed under the load. Now you can see here, there is a column, and you will see that the material of the column, that is concrete, is not able to resist the various type of forces when load is coming on the structure. So it can crush, it can bend, etc. So later on we will be trying to understand all these things. There may be bending, buckling. Beam can bend. Initially beam is a state member. When it is subjected to load, there is the possibility that those loads can bend the beam. If there is a column, load can buckle the column, or there may be some type of twisting also possible. Now you can see in this structure, it was a steel structure. Now you can see here, you will find some twisting happened. So that means twisting can be one of the reason of the failure, bending may be one of the reason, buckling can also. So from these three figures, figure number 1, figure number 2, figure number 3, you find there are some cracks, some crushing behavior is there, some bending is there. And all these happen due to some forces, because load itself is a force. So when force is applied, or when load is applied, some stresses will develop. We will try to understand what is the meaning of stress. There may be change in shape and size of the structure when load is coming on the structure. So that may be one of the reason of the failure. So ultimately a structure can collapse, it can fall down, it can collapse. So these few reasons which we are trying to here elaborate there, that cracks, crushing, bending. So these may be all, may be the reason, maybe any one of the reason which will be responsible for the failure of the structure. So we have to understand all these type of things, all these type of happenings, and what are the causes of happening. If we are able to understand what are the causes of cracks, then during design we can take into consideration all those factors, and we can maximize the possibility of not coming any cracks. That means maximum possibility of avoiding the cracks, crushing, etc. So this subject is very important for all of you, because you will be understanding all the basic things, and which later on in your next subject, that is design, you can this type of knowledge will be very much helpful. Now here if you see this fourth figure, this figure was actually a slab and a column, and you can find out that this column is getting punched out of slab. So this type of failure is known as punching failure. So what are the reasons of these type of failures that we have to understand effectively. So all these parameters, all these regions, all these figures point out to understand what is the strength and other properties of the material used in construction. That means if you are aware about the strength properties and maybe some other properties of the structure, then you can make it safe. So let us continue. Now, prime focus is on the strength of material. That's why this subject is introduced. First of all, which material you are going to use, whether it is concrete, cement, concrete, maybe wood, maybe steel. You must be aware about the strength parameter of the material so that you can build a or design and build a safe structure. Now, when an external force acts on a body, the body tend to undergo some deformation. Maybe initially a beam is a straight horizontal member. When it is subjected to forces, it may try to bend. So that bending will come under deformation. Maybe if there is a column and it is going under compression, it can possible that column can have deformation, column can buckle. So now what are the external forces? What do we understand by external forces? External force may be self-weight of the structure. There is a beam, beam is made up of some material, material has some weight. That means whole of the beam is having some self-weight. So that self-weight is responsible or it is applying some force. Imposed load. Imposed load mean that mean it is not dead load. Self-weight is a dead load, but imposed load mean you are applying some load from outside. Maybe when you are using it to any type of load, which is not basically a fixed load, then it will come under the imposed. You are imposing some load on the structure. There may be some tensile force. Tension, you may be applying some tension. There may be some compressive force, twisting. That means you may be applying some movement on the structure. When you are applying some movement, then it is also known as twisting movement. So these all come under the external forces. And when an external force act on a body, the body will try to undergo some deformation. Now, what is the meaning of deformation? Broadly, we will try to understand meaning. Deformation may be any form of as structure. As suppose there is a column can get shortened, or then if you apply some tensile force, then that member can elongate, or if it is a beam subjected to some concentrated load or some UDL, then there may be bending. So if the beam is getting bending or any structure member is getting bending, it is getting shortened, it is getting elongation, all these comes under the deformation. And what is the cause of deformation? External forces are the cause of deformation. So it is very much clear from these three paragraphs that when some external force is acting on a body, it can cause deformation. Now, when deformation, what type of deformation, we will later going to explain. Now, that means material of the body opposes the deformation due to inherent strength. Suppose there is a steel rod, and if you are applying some force outside, suppose this is a steel rod like this is a steel rod, and you are going to apply some force outside, then what can happen? This steel member can elongate. So there will be some deformation, that is elongation type of deformation will be there. If you are applying some compressive load, it can get some compression. That means decrease in length. That is another type of, that is shortening of the member. It is also called deformation. Now what will happen if you apply some force? Then it does not mean that on the application of that force this member will get elongate. No. So if it is not getting elongate on applying the force, if you go on increasing the force, then maybe at some stage it can elongate. But before that, when it is not getting elongated, that means to the applied force your member is responding, it is applying some, it is resisting. And why it is resisting? Because of its inherent strength. The member has some internal strength, it will try to oppose the external force. Body mean that material body will respond to external forces, which depends upon now how much response of the body, that means the resistance of the body, that depends upon the material type. Material type means whether it is RCC, whether it is steel, whether it is plastic, whether it is wood. So type of material, as you change the type of material, response will change. Then cross sectional dimension, depending upon what is the width of the section, what is the length of the member, etc. So all the cross sectional dimensions will also affect the resistance to the external forces. And this response, response is basically termed as resistance or resistive force. Now let us try to understand. There is a member and we are applying some force from the outside. You are well aware what do you mean by the applied force. The applied force can be compressive, can be tensile, etc. So when you are applying some tensile force, what will happen? The member, due to its strength, it will resist. It will offer some resist. And this resistive force is known as reaction. Now this applied force will be called as action, and resistance offered by the member is known as reaction. So how much will be the reaction? It depends upon the properties of the material, dimensions of the material, cross section of the material. So what will be the resistive force? It will depend upon all these parameters which we have already discussed. So very important punchline is resistance force offered by material is due to intermolecular forces of the material. You are well aware that molecules of the any material have intermolecular forces of attraction. When you are applying some force, then they will try to resist. And the deformation start when resistance force is less than applied force. That means if you are applying some compressive force, suppose it is 100 kilonewton and maximum resistance offered is 90. So after 90, when you increase the applied force, then this structure, this member will get compression. It will get compressed. And if you are applying tensile force, then it will elongate. And that means we will say now the member is getting deformed. So deformation start when your applied force is more than the resistive force. Now we can see one diagram here. What you will observe, there are two columns are there and one beam is supported. That means these columns are supporting the beam. Now this beam has self weight. No external force is applied. Due to self weight, what will happen? Due to gravity, this self weight will be acting downward. Now suppose these columns are not of a good strength. Suppose these columns are of paper. These are made up of paper, but this is a steel rod. Then what will happen? This beam will go down. Now, if these columns are of good strength, maybe they are of RCC or steel, then what will happen? Now this RCC beam, these column will apply or resist the movement of this beam. If these columns are resisting the movement of the beam from getting downward, that means they are offering some resistance, and these resistance are known as the reactions. Now in the second figure, you will see if this beam is getting loaded, you are increasing the load, then possibility is that this beam can bend like this shape. Now this is support, this is support. What you are observing, the upper portion of the beam is getting compressed and the lower portion of the beam is getting extended. So that means at lower portion, this is blue portion, tensile force is acting and above this compressive force is acting. So that's why this beam is getting bend. So this is known as bending, and some bending force is applicable on it. Now let us go through some important definitions which we will be using throughout the subject. Now how you define a force and how you define a reaction. Force is also a reaction and the reaction is also force. External force, whether it may be push or pull, it may be compressive force, it may be tensile force, applied on a body will be considered as a force. And the reactive force, now you can understand this is also force. Reactive force offered by body is known as reaction, which is the response of the body. That means what is force? Force is the external force applied by any means, and reaction is also a force that is resisting, that is due to the resistance of the body, which is the response of the body to the external forces. Now very important thing is to obey law of static equilibrium. That means it is very much clear that every member, whether it is a beam or whether it is a column, it will try to be remain in the state of static equilibrium. Static equilibrium means at rest. That body will try to at rest. Now, if you are constructing a beam on a column, then what is our requirement? That beam should remain stable. Beam should not move. So it should follow laws of static equilibrium. Now again we are seeing the same figure. Now beam is applying some load, and what you will observe, let me go back. These columns are applying some reaction. If these columns are able to apply some reaction, respond, then beam will remain stable. Or you can say beam will remain stable till these columns are able to resist the load coming from the beam. Now another definition is stress. Stress is force of resistance. Now it is very important to understand that means stress is what? The response of the body. Force of resistance per unit area. Now here if this is a force, then force may be acting on some area where force is applied. So when you have to discuss about stress, what is stress? It is the ratio of the force of resistance per unit area. That means force divided by area will be stress. Now here you can understand more effectively. This is the applied force, F is the force, R is the reaction or resistance. So mathematically, formula for stress, sigma is equal to R upon A. And this R will be equal to F when there is no deformation. Let us understand it effectively. This magnitude of this R will be equal to F when there is no deformation. And when F is more than R, then deformation will happen. And when deformation will happen, then stress will not be acting on it. So what is stress? That means how the body is responding. When the body is responding without any deformation, then that resisting force per unit area is stress. So for static equilibrium will remain till R is equal to F. And when till R is equal to F, that means there will be no deformation. When there is no deformation, it is static equilibrium, where F is the applied force, R is the reactive force, A is the area cross section. Now this is a structural member, so it may be like this. This will be the area. If it is a rectangular member like this, then this area will be the area cross section. So when reaction is applied on the body or applicable on the body, then sigma will be intensity of the stress, and it can be given by this formula. So one is force, other is stress. Now let us talk about the units. Now SI unit. Unit of stress is Pascal. That is pressure basically. And in practice, bigger units are used like megapascal and gigapascal. So 1 Pascal is basically 1 Newton per meter square. When 1 Newton force is applied on a cross section area of 1 meter square, then the stress acting is 1 Pascal, and 1 megapascal is 10 raised to power 6 Pascal, and 1 gigapascal is 10 raised to power 9 Pascal. So again, we have to keep in mind this tagline, resistance, that deformation starts or occur when resistance force is less than applied force.